Bushra. She's oncology and she's the director of the Oncology Center in Agadir. And my friend, Professor Khabar Youssef, he's the pharmacologist and he's the physician in our university medical school, and also he works at University Hospital of Agadir. So, well, let's go and start the session. Thank you.
C'est bon. Donc, thank you for Professor Abawi. Donc, good morning, everyone. Donc, dear colleagues, dear speakers, participants. It's a real pleasure to welcome you to Session F, Education Generative AI and Future Vision on this third day of this conference. Before we begin, I would like to warmly congratulate and thank the organizing team for their outstanding work in putting together such a high-quality scientific program. This session will be chaired by me and by my friend, Professor Bushra Amawi. So we will start with Dr. Elk Noor Turkmen. So the floor is yours. Donc, application development during life, DP implementation, challenge and advantage.
Yes, welcome. In the last morning, good to see you here. And I want to thank for the introduction and for invitation to the Congress. I will talk on our app list development experience we had in the last 6 years, what we had, and how to do it better can be a good lesson. Who we are? We are a group of 13 hospitals from 6 different cities in Turkey, and we have patients from over 150 countries all over the world. And the pathology department went live 5.5 years ago. We have 25 pathologists working subspecialized. And in Istanbul, only 8 of them are in Istanbul. They are all around the country. We have 73,000 cases per year, and we produce a data of 2 terabytes every day. And we have a full digital workflow and tracking with full digitized for biopsies. And we are an ISO accredited lab. And what we talk every time, also here in the first 2 days, digital scanning is not the beginning of digital pathology. And for digital scanning and for digital pathology, we first want digital workflow. And after that, you produce a standardized gold standard glass slide. Then you can scan, and you can report your cases digitally. After that, you can use AI and clinical decision support systems. All the loop is completed. So when we are talking about AI, we are sure that you have a digital workflow. Otherwise, you cannot send the cases to the AI application. And for digital workflow, we need tracking, dictation, barcode readers, computers, and integration to electronic health records and hospital information system. And this site is not as expensive as scanners, and you can start today to do this. You may not have the money for the scanner for now, but you can digitize your workflow step by step with less budget than scanners. And you will be ready to buy the scanner when you convince your C-level directors. When we are talking about pathology workflow, to not have the mismatches and have the quality in the lab. Then we are ready to look at our slides. And at this stage, we have the IMS and Weaver. And when reporting, we need EMRs to evaluate the case properly. And we can use the decision support systems and AI tools at this stage. Then we prepare the report and send it to hospital information system. All the way, we have quality assurance issues, and we need data for that. And I like the term data-proven lab management. Applis is the tool to combine all these and have them appropriate places for patient safety. And all the way, we need data, we produce data, we use data. This is important in the era of data. It is important that you get data from Applis from every stage. For this, you need complex interaction between the systems. We decided an Applis-centered workflow, and it is also recommended by several communities as well as Afsdp. And I like the term pathologist cockpit for defining Applis because it is in the center and it communicates all the systems. As you see, the communication is complex, but being Applis in the center, being it as the backbone and the brain of the workflow is important and makes it, for you, the invisible work visible and measurable. You have fewer errors with tracking and Applis use. And if you have an error, you can follow up and make the quality assurance steps. So Applis is the center of digital pathology. You have the devices connected to Applis. You have IMS, Hospital Information System. All the hardware and the software are connected to Applis. The scanner and AI is at the other end. And to communicate all of them and to combine and collaborate all of them, Applis is important. But communication of this system, this complex communication, is not easy to achieve because you have different vendors, you have several conflicts between the vendors, the standards are not so well established, and you should pay for it. And when you learn that, you should pay the integration. The vendors want to integrate in the least side, but you want a huge integration, and step by step, every integration step is problematic if you don't plan at the beginning. So we should be careful about the integrations, plan in details. And there are guides for interoperability, and emphasizing that using Applis more than hospital information system pathology modules can be more detailed and good for pathology workflow follow-up. And there are discussions for the standalone list or laboratory modules incorporated in hospital information system. There can be pros and cons, but the important thing is the team, the IT, the laboratory, and the directory part should think together. When you have this at the accession, you can manage the paperless laboratory, you can make the QR tracking, and you can manage the multi-center management, because we gave the biopsy numbers unique and from 13 hospitals. So APLIS manages the uniqueness of each specimen. Then from these 13 hospitals, the specimens comes to Istanbul, sometimes whole specimens, sometimes gross specimens with the cassettes come to Istanbul, and we manage the transfer on APLIS. And the transfer module was achieved, I think, in the second year, and we used Google Sheets to follow the transfer things, who sent what, in which bag, and where is the bag. We put some Excel sheets, but now we can manage it on APLIS, on the patient, specimen, bag, and hospital details. And we are trying to make a GPS tracking for the bags. We didn't manage yet, but it's in the plan. At the grossing stage, you can see the radiology notes, operation notes, macroscopic images. You can take the images and upload it to the IMS. You can put notifications on the photos that which block is where. It is important that the communication is seamless between the pathologist and the pathology technicians, because they are far away. So from grossing, pathologists should be sure about the specimen. We have dictation system, and you can track every cassette on the grossing. At embedding, we have QR tracking at the case, and cassette level control can be possible with this. And we take notes from the grossing. For example, this is small, be careful, etc. And record notes for the sectioning and give feedback in every step. And if there is a mismatch or a missing cassette, the system doesn't go to proceed and let you find where is the problem and fix it. On the sectioning and staining stage, we have the list of cassettes, and we match the cassettes and the slides. If non-matched, you cannot proceed. For the last 1 year, we are printing the glass slides printers beside every microtome. It is easier, but what APLIS informed us, we had a problem with the glass slide printers, that it printed double glass slides. And without matching, we had some matching problems. So this QR tracking is so important for the patient safety. And you can report who, when, and which block or glass slide is in the action. Before APLIS use and digital workflow, every time we asked who did this, and nobody does, you know. But with APLIS, you don't need to ask who. Then at the delivery stage, we can have the workload metrics at the case, glass slide, and IHC details. We can take notes from the previous steps and record notes for the next steps. For example, a case having a bone tissue remaining in the acid processing is informed to the pathology on the system. And at the pathologist working station, we can see the previous biopsies, radiology, clinical notes, and we can give feedback if anything goes wrong on APLIS. As you see on the left, at the COVID time, we started a short time with microscopes. Microscopes are historical on our table for now. When there is a crisis, nobody wants to use microscope, and everyone says, scan my glass slides, please. At the validation periods, people ask for glass slides, but even if for example, we have downtime times, and even if we send the glass slide when the scanning starts, they want their glass slide scanned. The paradigm shift is something like that. And for the pathologist work list, we have priority cases or delayed cases informed here. We can customize our work list, which system we want we can put. We can see the reports directly from the list, and we can search what we want according to the which parameter. We can search everything and form lists. After that, for the additional orders, IHC and the others, recast, etc., we want it from the list, and we get reports from that. Sorry. And also, it is good for the follow-up of repayments of IHC. We are a private hospital, and we may have repayments for the cases, and we have the lists, and trying to make it seamless integration with the hospital information system for this financial part, but it is not completed yet. Yes, is there an ideal APLIS, or how can be an ideal APLIS? This paper is good. As you see, the communication is complex, and what I want to emphasize here is the data mining and financial part is advised to be done on APLIS also. We are not at this stage for now, but we are trying to have the detailed data mining and the financial control. And also the integration is important for the ideal APLIS. If you have a primary vendor to make the integrations or link the vendors, can be discussable, but don't forget that there is no guarantee that you will not have a problem in integration. Honestly, it is guaranteed that you will have problem in integration. So, what we had in our APLIS development journey, the ideal APLIS is defined as tailored to lab needs. Yes, it was an advantage, but our disadvantage was that we start without a planning phase because of the directory things, financial problems, and I insisted on APLIS, and they said, you can use this because it is cheap now, and the APLIS was not completed. But I said, okay, APLIS is a must, and we can develop it. So tailoring is important, but you should tailor before your routine workflow, and you can make it before the scanners, yes. If you, before thinking about scanner, think about APLIS and digitizing the workflow. So this is the lesson we learned, and if I build another lab, I will start with APLIS. Then, IT project. It is an IT project more than a lab project, don't forget that, and involved IT people. What we had and what we will do different if needed is that the IT team was in, but both the vendor and the IT team was not aware that APLIS is a big project. So they gave, we had for 2 years only one coder. So things take a lot of time to develop. And, but we didn't give up the digital workflow. We used Google data sheets to, for the communication of people in the lab. And then all the system went to APLIS step by step. So lesson is that have enough and all needed people in the team and plan accordingly. If you have less people, you can say that you will start your routine when this milestone is achieved, and you may wait for that. Project management is important and a must. As doctors, pathologists, we are not familiar with the term project management. It's an engineering team, in fact. And I was the project management for a long time for this Apple's development. I'm a good manager. I have a lot of projects, but I am not a project manager for an IT project. So have your project manager from the beginning, and be sure that he or she links you to the vendor, to the coder, and what you say and what they understand to align them. And differences among labs are important, and vendors visit a lot of people, a lot of labs, learn a lot of things, get a lot of feedback from other labs, and they think that it is okay, and they insist on making them true for you. But it is not the case, and the coder, I insist so much and invited them so much, please be in the lab, see what we are doing. And later on we can go on, but I couldn't manage this. So this is important that you have the coders in the lab, Jordi says, knows. And be sure that what you are saying, what they are understanding. We have several scenes like this. You said this. Yes, I said, but what did you understand? So there are a lot of discussions on this. So the communication and the coder should know what to do, what you want, what you are doing in the lab. So for the software development, this cartoon is so good. This is how the customer explains it, and in every step, it is so different. You tell something, yes, they understand and say, and one thing is that they want to give you a marvelous thing, but in fact, you are hungry and only want bread, but they insist on that, I will make a cake, it will be so good, and please eat that. But I don't want cake, I'm diabetic. But they insist on giving me cake. Bread is enough in the beginning. So, explain. Explain what you want, show what you want. Be sure that what they understood, read back. In military, it is a rule, as you know, read back. And for the critical diagnosis, we have a read back procedure. But be disciplined, military discipline is needed at this stage. Read back, say me what I said. It is important. And see how they design and write. Because they write, yes, why our coder was genius. I love him, so genius guy. But the coming thing is not appropriate for you. So you should see their design and what they wrote. And document everything. At this stage, for example, I cannot give you how we developed, when was the milestones, nothing was documented, and it is important. When you go back, when you have discussion, you said you did, etc., documentation is important. And see and test the installation. Even for now, every sprint is a trouble for us. In the morning we come and a lot of things changes, a lot of updates, and working things go problematic. So every sprint is a problem, and testing is important. Be aware of the billing strategy, because in our case, both the company and both our directory, the decision was made because they were cheap. And they said, oh, okay, Iknur, we will make it in 3 months. And we are in the 5th year, and it is developing. So even the vendor doesn't know what is appless, what is it needed, how big it is. So you should tell the details, very detailed. And you should guarantee the technical support. In every case, this is a problem. In every software, in every vendor can be a problem. So the technical support, the local support is important. And be sure what you want and what you need. Otherwise, you will have something from Aladdin's lamp, what's coming, and wait for it. For the Appless development, there are a lot to read. This is from Leeds Group. And this sentence is the first rule. Any change to existing laboratory software, for example, this, should be completed before the digital pathology becomes routine, the first rule. Then, informatic-driven quality improvements in modern histology. I have this thing, yeah. And I like this sentence. Go live is not the end of list customization, just the beginning. Be aware of what you will have. Anatomic pathology, Appless review from Parvani group. It's good to read. And there are some laboratory information system functionality assessment tools, also advised by Afsdp, can be used in your Appless developments if you decide to develop it yourself. And why do you develop? And after development, what do you do with Appless? QA is one of the most important topics for me. In my previous institution, also, I was keen on QA and made a lot of things without Appless. You can do it with Appless, without Appless also. I like this sentence from Peter Drucker: you can't manage if you don't measure it. So Appless is so good to measure what you have in the lab, because you make tracking in every step. You can make the workflow control in every step, in every action. And you can have lab feedbacks. It is structured and easy if you plan it good. You have measurable parameters. What I had in my this 6-year period is that pathologist's workload is so difficult. Everyone knows that, because quality and quantity, and you cannot measure what with that. And we had a lot of struggle with the workload distribution. But with the use of the data, we are now safe, we are happy, and we are peaceful for the workload distribution, because I share the workloads every week and every month with all the pathologists in the group. Everyone sees who does what. So nobody thinks that she is the most hardworking one in the lab. Everyone is the most hardworking one, you know. And you can report and analyze the data, and you can manage your lab with data. And the most important thing is you can distinguish the staff problems from the system problems. Because if you have a problem in the system, you cannot manage it with the staff. If you have a problem with the staff, even if your system is marvelous, you cannot manage it if you don't focus on that person. So Appless manages the quality assurance by this. Is it a mess? Is it a must? No, you can make it. These are my Excel pivot sheets for the QA issues, because this QA part is under construction at our Appless for now. I got some reportings from the Appless, but do a lot of calculations and use the data and see what is going on in the lab out of Appless. But the dream is that the matrix scene, I will see all the things in my room, is the dream. And why important for quality assurance? Because in quality assurance, you generate data in Appless, and you use data in QA, and your data is standardized, planned, and you have an easy entry and collection way with the Apples. You can determine the targets, and targets are numerical. You have the quality indicators from the Apples, and you can collect daily feedback. And with this, at the end, you have a data follow-up and you have a digitized data so that QA is not on the paper. We have an audit 10 days later, but we are always ready for the audits with this data management. But this part, some of the parts of this is under construction again. You have the lab feedbacks for QA. We have the feedbacks, but managing is outside the Apples for now. We are going on. We can report and analyze the feedbacks. Where is the problem? We solved a lot of problems with this feedback system because if you give feedback to the people on specific actions, they learn and make it better. And for the lab and QC metrics, data generation and follow-up is possible with Apples, turnaround times, workload analysis, internal and external consultations, and differences in the diagnosis in the external consultation cases, for example, frozen QCs. We have the time and accuracy. Biopsy cytology compatibility things are managed from the data, but there are things going on for development. There are under construction. And this is my dream. It was done 3 years ago, and I'm waiting for the updates. I cannot use this for now, but I will. I want to thank the whole team of Memorial Pathology. Digital pathology implementation is a team issue, and you should have your secretaries, your PAs, all the pathologists in the team. As well, the IT guys, the vendors must be in the team. It is so important. The most important thing is who is coming with you on the way, and the team should be whole. And I want to remind you for ASDP, Asian Society of Digital Pathology. So we will be happy to have you in ASDP. We have a DPX project in ASDP, Digital Pathology Implementation Exchange. And we are sharing our experiences, not lighty success stories. We share our failures to guide the newcomers. So we will be happy to have you contribute to DPX, learn from DPX. And I will be so happy to have an article, for example, for African digital pathology status in DPX, so I will talk. And I'm happy to welcome you to our annual congress in Singapore in November. And have you as the members of ASDP. It is free for the trainees, so we have webinar recordings, a lot of education material for the digital pathology implementation that they can guide you. And I end with love from Istanbul, with the colors of Istanbul, and thank you.
So thank you, Noor, for this presentation and for sharing with us your experimentation about Apples development. So I think we will move in the next presentation and then.
Okay.
What do you think?
I can have questions if there is any.
Yeah.
Wonderful, presentation as usual.
Thank you.
Very much
Thank
impressed.
you.
So yes, the more we work with the police, the greedy becoming, because I want to have this function, I want to have this function. But, I think, like I say, even in Japan and in many countries in Asia, and also same as in Africa, there are several institutions who cannot really go to the pricey apples because apples is not cheap, actually. So is there any minimalist type of the apples, or if you really recommend people to start creating something inside the apples function, what would you recommend? Is there any choices, any?
Tracking is, I think, should be the first step. It is also to make readiness for digital pathology, lab tracking for patient safety, accession included in tracking. And if you report from lists at the beginning, it can be something first step. These QA issues can be in the second or third step, but you should plan that to want from the developer.
Thank you very much.
Thank you.
You talk about many step to develop your system. Yeah. What is the hardest step to for you?
Convincing the payers, the C-level. Integration was hard and still hard. Every integration, because for the integration of IHC devices, for example, I think, if I don't remember wrong, 1 year. I waited 1 year because the vendor wanted 20,000 USD. The directors didn't want to pay, and we paid, I think, 1/4 of that 20K, and we integrated. And they are now doing the PR that we are integrated to Applis, we are digitized, they are doing, but I know what I lived. So integration is the hardest one. Human, yes, people.
You talk also about manager. For you, what is the best, to have an external manager or internal manager?
External, but linked to you very appropriately. Because, for example, when in the developing stage we had a pathologist having coding skills also, but managing is something different. And the coding skills is not at that side. And I had the managing side. After 3 years or 4 years, I think there is a project, in the third year, there's a project manager in the team. The problem in our case was that the company was an AI producing company, and Applis was something to give with AI, and they said, we are developing Applis for you. We are not an Applis company, but they are going global with their Applis now. So after that, the team is, I think, now over 10 people in the vendor side, but we started with 1 coder. And we go like this, I think, for 2 years, maybe 3.
I have one question, practical. We try to make something like what you show in the University Hospital in Agadir. We have just 1 coder also. And we work on it one years ago. What the best advice you can give to us to move on, to make it like what you showed?
Thank you. I can talk to the coder. Thank you.
Thank you very much.
Thank you.
So, thank you very much.
Thank you. Thank you.
It was tamam. So, we can move to the next communication, and we call Mr. Ihsan Ola from New Zealand. He talk about practical guide to pathologists to use generate AI.
Yes. Ihsan makes a long journey to come to Agadir. Welcome to Agadir, Ihsan.
Thank you, and good morning, everyone. I'll be using my laptop here because I wear progressive lenses with high power, so I cannot kind of, look there if I need to look for something, including time. So bear with me for a second when I just turn on. Okay. So I would like to thank Afsdp for hosting me here, as well as DPA for sponsoring the travel. This was a long journey. Took me 54 hours. Because when I reached to New York, the flight to Casablanca was almost leaving. So I had 24-hour layover there. So and right now, it's actually time to go to bed in New Zealand. So if I go to sleep, please wake me up. And the topic today that I'm going to talk is basically practical guide for pathologists and anyone else in pathology. Could be technicians, could be your computer scientists. Computer scientists would know, but probably those who are not computer scientists. It's for them to use generative AI. And since the day before yesterday, I have also listened to many talks which go at length in this topic, so I will be skipping a few slides so that I keep the focus on the real few slides. I want to basically go in detail and don't want to bore you guys. So, after just a little bit of introduction and thanks, I just want to give this disclaimer. I'm not associated with any digital pathology vendors, though I have my own startups. And if I name any digital pathology vendor or any product from any company, that's just for purely educational purpose. There's no intention to promote anything. So, as I said, I'll be skipping a few slides, so I'll just very, very briefly touch on the key milestones in AI and generative AI. And then the key component will be the slides with a black background, which start with the million-dollar question, how to learn generative AI. You can sleep, or I can skip all the slides here and there in between and after, but the real focus is going to be the in-between. So yes, I mean, everybody knows by now that yes, since ChatGPT came in, everybody kind of became almost an expert in generative AI, whether they are or not. But I think generative AI is so user-friendly that the day you start to kind of use it, it gives you the ability, because it's a conversational model, you ask the question, and it gives you the answer. My 5-year boy, he gives me like a challenge. Dad, can you name 10 herbivore dinosaurs? And I can't think of even 10 dinosaur names. And then he would say, ask ChatGPT. Like the 5-year boys. And this is important to understand because our younger generation is well versed with these technologies, and we need to kind of take that in when we are talking to our trainees, our technicians who are coming just out and into the profession. We need to know that these guys actually know more of these technologies. We need to kind of take advantage of that. I'll skip this slide, but just probably next slide is relatively important to basically appreciate that generative AI is pure science. This is not pseudoscience. 24 Nobel Prize testifies that it's here to stay, and the advantages of this technology actually outweigh the disadvantages. So the role in pathology has been discussed in detail. This slide gives you a very brief overview. You can read, I can go through it. We can go through the next slides just to kind of brief over the unimodal application, which could be text to text or which could be image to image. Unimodal is where only one mode is being used. Examples would include generating summaries, extracting text from unstructured pathology reports for cancer registry, for synoptic reporting and things like that. Or it could simply be virtual staining. So you use the image of unstained and you convert that into H&E or a biomarker with IHC. A little bit more about unimodal. We're gonna skip these slides. And then multimodal. That's when you combine two modes. Say you got the image, and then you also want to ask questions about that image. And you want to kind of generate like a basic pattern recognition type report so that you can guide things like reflex testing. So based on the pattern on your H&E, your system could be linked up and can direct immunomarker staining in the lab before the pathologists have actually seen the H&E slides, things like that. So these are the various kind of phases within the pathology workflow which AI can drive, right from scheduling and triage of the cases, to decision support, to reflex testing, to quality control, and the report draft generation, including synoptic reporting. And some of these actually don't even need you to have digital scanners. Some do. For instance, if you want to basically implement some automation with AI in the pre-analytical phase of your lab work, say you want to automate the registration step. Right now, you have got your, say, pre-analytical technicians. They are reading the lab request form. It could be typed up or it could be handwritten. And then they are actually using their brain to kind of understand and then typing it up into another LIS system with sensors. Sorry. This can be automated. Simple. This does not require you to have even digital pathology. It can be done anywhere. Now start the most interesting and important part of the presentation today, the million-dollar question. Which AI course should I buy for my team? Any ideas? Okay. Look at this slide. This tells you the problem. Why you can't find the best training course. Because the technology is developing so fast. And the curriculum development takes longer, and it's actually behind. It's just like behind, like regulatory bodies are behind. Everybody is behind. Just the technology itself is actually just having a rocket booster kind of speed. So the other thing important is that even if you got a training which is actually being refreshed every 24 hours, they are going to teach you general, abstract themes. They are not going to talk about very specific problems that your lab workflow requires. Because the daily operations, they require hyper-relevant solutions for the very much of your own context. And that is driven by the robust knowledge of what actually eats your day. Whether you are a pathologist, whether you are a technician, what is the most time-consuming, what is the most repetitive, what's the most boring task? And that is what you can actually, you know that why not? If I ask a technician, they would tell me, oh, I actually spent this much time on this task. Pathologists will say, oh, okay, I've done my job, but synaptic reporting is taking a lot of time. So all these things are known to those people who work in the system, and they could slightly differ from one lab to another lab. So the workflow expert is already on the payroll. That's you, your team. And the true promise of AI is extreme personalization. No external curriculum knows the friction points in your workflow. You are the expert in your own workflow. So in the next slide, I'm going to give you a playbook with 4 steps that you can use along with your expertise to actually start using generative AI. So this is the 4-point playbook. I'm going to explain each step of this playbook in the next slides. And just to be mindful that I actually developed these slides by putting some of my information into Notebook LM. That's freely accessible tool from Google. Right. So the 4 points are: find the target, find the tool, then use it securely. Don't push your sensitive information, personally identifiable data, and then map out your rest of the journey. So you have started now, and then you have to kind of build from there. Let's talk about each of these steps in the next slides. So how you can find your target? How difficult it is to find your target? You know what's the most time consuming? Put that on your y-axis. Every task in the lab from minimal time to maximum time. And then on the x-axis, you can put highly repetitive and boring tasks. That corner over there will tell you that is the target point where you can start using AI to automate or get help from. Now, unlock the hidden sandbox. Whether it's ChatGPT or Gemini or Claude or whatever, you can start with the free tier applications. No harm as long as you're going to use it securely. But the other thing is you might not know, but your organization might have purchased an enterprise solution for these or one of these. How many companies are using Microsoft? They would have access to Copilot as an enterprise solution. So they assure that the model will not be learning from your data. So basically, there is tool already purchased by your organization and it's readily available to you. Now, this is very important. If you're using free tier solution, and I would say even if you're using an enterprise solution, be mindful of the security of your critically sensitive information, your patient names, their location data, their NHI numbers, or whatever identifiers are there. You cannot just expose these things to any of the generative AI models. what's going to happen in a few years? An Epstein file will open for you, and you will have no hiding. As simple as that. So, some solutions. You go in with a zero training architecture. If the model allows you to turn off the data training, do that. Then anonymize the subjects and sanitize the enterprise secrets. Remove those from your prompt. But it's difficult. I mean, it's difficult when you have to actually use a large text and you are trying to anonymize. How easy it is to actually do it. Not so easy. You will spend the same amount of time on pulling all this data. You could have done the job yourself in almost the same time or less time. So here is a solution. Now, I'm not sharing this for promoting my solution, but this is the problem I had, and I wanted to actually get rid of the problem I had. So I developed this privacy gateway, which is agnostic of any generative AI models. What it does, it takes out all the personally identifiable data from your prompt, and whether your prompt is just a text, or if it's in a form of Excel sheet, or it's a PDF document, or it's an image, or even if it's like a voice note. So it converts that into text and then erases the identifiable information. And when the answer comes back, it puts back your personally identifiable information into it, so your experience remains seamless. You don't spend more than a few milliseconds. So just plug in and play. Now, once you have started using either like a free tier or an enterprise solution, and you have ensured the privacy of your information, then you need a roadmap. Like how I'm going to actually develop this application, or how I'm going to actually reach to my endpoint. You can ask it. You don't need to go to a course. You can simply ask that this is the problem I'm trying to tackle, this is my role, and I want to achieve this. The same model will actually tell you the roadmap. Okay. Again, I'm not against any courses that you want to take, but just understand, they could be outdated on arrival. Any courses could be outdated on arrival, whereas your in-house advantage evolves with the tool. So you are actually using the tool, you are expert of your workflow. As new challenges come through and you are asking the tool, it's helping you through. Then focus. It will be hyper relevant to your context and your lab if you are actually directly taking your expertise and asking questions about it from generative AI directly, rather than going to a training course where people will just talk fluff. They don't even understand your workflow. And because they are a coach or a trainer, they have to speak. They would just speak nonsense, honestly. I have attended so many training courses. I've attended some from, I'm not going to name the big organizations, but no, they actually don't solve the problem. The ultimate return of investment flywheel is basically comprising of these three components. Experiment, you test your internally, your internal friction points with either a free tier solution or an enterprise solution, and you build a custom solution, whether it's ugly looking, it's okay. It's a starting point. and then you scale it up. Only when you have a custom solution, then you can go to external vendors and ask them to actually refine it, move from proof of concept to like a commercially viable product. But the starting point is actually coming right from within. And the key message is, stop trying to learn about AI. Start using it to solve your problems. Now, I have a lot of other slides, and we can go through those depending on time. I don't know how are we running with the time. Okay. So I can basically go through a couple of use cases which would be relevant for Africa as well as AFSDP. The first use case is from my lab, where we automated the transcription and formatting with LLMs. So we just use ChatGPT free version, and we're talking about December 22, when ChatGPT was like really new. And we just used a plug called Whisper that converts the audio into text. And then we use ChatGPT itself to basically format it into our clinical format. And can you believe the results? It was almost as accurate as our experienced transcriptionists, but as compared to them, it was only taking like 17 seconds, whereas they take about 6.5 minutes. So it's no-brainer, basically. We can refine it with more data, but the solution is already there. This is when I was saying the ugly solution right from your workflow, your friction point. Now you can take this idea and go to an external vendor and ask them to kind of scale it up. Now, second use case is extracting structured data from unstructured pathology reports. And we did this work to automate the cancer registry work at Moffitt Cancer Center. So we used open source models in 3-stage approach, where first layer of models was basically fetching information independently and then handing it over to the next model, single model, that was actually checking. So there was 11 models being used, all open source, and they were independently answering the question. And then one was checking whether, okay, so out of 11, if 10 or 9 have said the same thing, it's gonna produce the answer. Where there is like 7 models saying left and 4 models saying right, then it was going to check it again and give an adjudication. And the results were impressive. By variable, we used 6 variables. We used cancer site, laterality, tumor stage, grade, histology, that means histological diagnosis, and tumor behavior, malignant versus benign. So impressive results here. And by cancer type, you can see brain was actually giving us some headache. Could not understand why. But otherwise, it was all fine. With brain, there was like little information in the initial report, probably. That was the reason. Because then they were asking for molecular testing, and that result was not available. And we were actually using any pathology information available within a week's time. And those tests were not available. They were available in like 2 to 3, 4 weeks' time. So that was probably the reason. Otherwise, cervix was just over 90%, but others are actually quite close. And third use case, synoptic reporting. This is not my experiment. This is from basically Mayo Clinic at Rochester. They applied LLM to fetch the raw text from pathology report and other electronic health records in the hospital to automate the synoptic report generation. And they also have quite impressive results. You can see them here. It's over 80% for short clinical reports and nearly 77% for the overall. That's pretty impressive. And at no cost. I mean, they have the open source models, they have the GPU in-house, and they can do it. Whereas, the commercial product is very expensive. Has anyone using a commercial product called Intuitive for synoptic reporting? How expensive it is? Do you know the cost of it? You're a free user. Are you a free user, but your institution is also a free user? Just ask them. If you ask them, you will realize how expensive it is. But if you actually build something in-house, that's gonna be with you forever, and when things change, you can easily change. For any commercial vendor, they will also change. They will send you an update, and you go through another training, and if they have look and feel change, then they give you training. Otherwise, they just, in the background, they will send an update, and if the new classification has come, that will actually flow through the system. Now, impact of generative AI on workflow. A couple of slides, not a lot. So in the pre-AI days, your administrative tasks are actually eating up your day. And where with the use of AI, the real aim is actually to give you back that time. So your administrative tasks would go down to like less than 20%, maybe 10%. And the time that is saved then can be used for in-depth analysis, interesting cases, educational, and innovative efforts. So that's the real aim and the real benefit. We're gonna flatten the administrative spike. At the same time, we don't want to actually lose the critical appraisal and deep analysis. That's the human uniqueness that we want to retain. And AI actually support that if you use it in the right way. You use it to actually get rid of the boredom, the repetitiveness, and the time-consuming administrative tasks, while keep the most critical decision-making, the new knowledge development, other critical thinking involving tasks to yourself, with a human-in-the-loop kind of approach. I think I will stop here, because the next slides that I have in my pocket, they have an overlap, and almost like a complete overlap with Daniel, who's gonna speak next. So I will leave that to him, because we shared our slides last night with each other, and I'm just gonna kind of kill those, but I will just jump on to this slide, which actually gives you my contact details. And I'm here to ask, to basically, you can ask me questions, or we can have like maybe a couple of minutes of discussion, and then moving on to next presentation. Thank you.
Thank you very much, Ehsan, for your practical presentation. I think we can have some questions about your presentation.
Thank you. It's of course looks very smooth, to say that, for the reporting. One of the things I would ask you is, in Europe, for instance, there is a Rule 11, I don't know if you know that from the CE marking product, that states that every software you use in the process of diagnostics of therapeutic use, you have to have a CE mark. So if you're going to use this kind of generated LNM, how do you going to make sure that this is CE marked in your laboratory?
It would involve a process, and I believe generative AI can actually answer each step in that process for you.
I expected that answer.
Honestly, I mean, as you know, as a company director with a startup, when I have this sort of a question, I ask one of the models that we use. At the same time, we are using Claude and ChatGPT and Gemini, all the enterprise solutions. And whether it's like signing an NDA with another organization or actually developing a pathway for regulatory clearance, they are actually better experts than the regulatory experts out there.
I understand, but that's the problem when the notified body comes along and checks everything, then you have to show the whole traceability,
Yes.
etc. And I think there's, at this moment, let's say regulation runs a little bit behind on what's now in development, right? So, but we are stick to the regulations that are at this moment present. So maybe this gap will even grow, I don't know. But it will also hold back further improvement, or let's say, yeah.
It's a very valid point. I think we are all afraid because regulatory bodies haven't actually caught up, and that's holding back some of this development. But I think the easiest way is to actually use freely accessible, publicly accessible data to basically do the first step, which is like developing an ugly solution, and then go to a vendor who can help you scale it up and let you go through the CE marking. And then you can basically commercialize this product as well as you use it for your real patient data. I don't think you can use real patient data even if you provide full assurance like you use enterprise solution. It depends. I mean, I don't know about Europe situation. Even New Zealand, we have two-tier privacy law. One that actually stops you from using any commercially available LLMs. And secondly, there is a special law for the indigenous population. So the indigenous population have a right that their data does not fly overseas. So for them, we have to have an arrangement where if we want to use Azure's or any other cloud, the cloud must be available on-premise, onshore in New Zealand. For a small country, these
Same in
big...
Europe.
Yeah. So how we circumvent these problems is basically enterprise solution use does help a little bit. At the moment, we have gone live for all of the doctor-patient interactions are actually being used as an example where the transcription and then the clinical letter is all being done with the use of LLM because the cloud is available on-premise and the enterprise solution gives you some sort of fake assurance that they are not going to learn from your data. I personally don't agree with it, but our national AI governance group have accepted that. So yes, there are multiple hurdles to actually go through, but yes, you need a good project manager to assist you, and also, you know, you have to start your problem, use some sort of either like publicly available data in the beginning or synthetic data. We use synthetic data. We actually, you know, I myself dictated about 30, 40, you know, voice notes for Whisper to actually, they were not real patient data. I just faked up.
Yeah, well, maybe we will use, let's say we have an research platform also with 90 million records for pathology where vendors can put in a closed circuit to use to train the LNMs. So that's possible. We use it only, let's say, to help us understand our own process, so that we keep it out of the process still, so that we still comply with regulations. But yeah, I think that it's going to be in the future very challenging to see how we can integrate it. Thank you.
Thank you.
I discussed with my colleague, Professor Abawi, about automated synoptic reports. I discussed with my colleague about automated synoptic reports.
Yes.
What do you think about ethic and data personnel
Information.
Yeah.
So it's the same as, you know, we have the same hurdles as we come across Paul's question as well. Synoptic reporting in itself will not have a lot of personally identifiable data, to be honest, because we are only looking at the information from electronic health records, from radiology and from pathology, which is all clinical information. So you can filter out the personally identifiable data in the beginning before you send your prompt to an LLM. Other way around is to actually use a local LLM and train it. It takes time, it takes GPU, it takes energy in the beginning, but then it is like more secure way to develop this sort of application. But using commercial LLMs, it is possible as well by de-identifying, which is an effort, and that is the, you know, Prevexa, which is my solution, also helps in that perspective. Thank you.
I also have a lot of discussions in the world with that. The borderline is when you touch the data. So exactly what you say is, it works? Oh, no, sorry. So exactly what you say, if you just put one-on-one, put from the report transcription, that's okay. But let's say you want to do the grading for the breast, and you have the 3 elements, that's fine. But the moment you say it's grade 1, you're touching the data because you're making a calculation. Then you're hooked.
Yes.
That's your border. So if you do everything one-on-one, that's on level 3, what we say, then you're still in the clear. But the moment that you do a calculation or you're making it a condition to get a new question or not, that's your border.
That's right.
Any other questions? Our students are here, and he's not a pathologist, and he interests of AI and pathologists. I'm proud of him. He's from Marrakesh, and he make his stage here in Agadir.
Thank you, Professor, for the presentation. I'm sorry, I'm a little bit nervous talking to in front of all these international big bosses. So in my project, it's a demo, and the idea, I don't know if that answer the ethic question. I'm working on a multi-agent, not only multi-model. They are multi-agent. Everyone is specialized in a different task, and one agent is the idea of this agent is bypass the information, the patient information. So, for example, it's using 2 methods, ICD codes and a case example to match my patient information. It's like given another scenario. I don't know if this bypassed the ethical structure of any country.
Honestly speaking, I mean, I don't understand the complete ethical landscape in Morocco what the process is and how close it is to the probably to European standard will be probably the closest. We'll have to look at your solution in detail to kind of answer your question. Yes.
That brings up wonderful talk, but the comment brings up an interesting solution. There's a lot of data. We haven't talked about this in a while. We don't talk about it in pathology. It exists outside the clinical record. It's outside of HIS, LIS. One of my areas of interest is geolocation.
Yes.
Where that patient sits often is predictive in some ways.
Absolutely.
And it sits out of the usual regulatory framework because the person is not in a health system ecosystem.
That does make a lot of sense now. So basically, yes, I think we have regulatory experts in the room. They might be able to answer more. I mean, I only did one study in 2018 where I actually analyzed the European, American, and the Asian standards for the data, new data sources. Like people are actually putting things on Facebook, social media. So how the ethical lens we can put on to fetch that information for the benefit of the patients. And it could actually be used by, psychiatrists could actually assess people's, mental well-being from their statuses and comments they make on social media. That goes in that, I think, line. I'm not an expert in this area, so probably I would say, sorry, I can't answer this question, but it's a really good question, and I think it's much wider question for the ethics experts to kind of understand, and also put some standards around it. Thank you.
For Abdullah, I can answer for your questions about ethics. In Morocco, we have a legislation. It's called the CNDP. You know it, and you have to put your project to CNDP, and after we have ethical committees. So you can come after and we can help you to do it. Okay. Any other questions? So thank you for everyone. We can close now the session for the break coffee. 15 minutes, please. Thank you. Thank you, Hassan. Thank you very much. take a seat. Thank you. So after this coffee break, we continue with this session of education, GenAI, and future vision with the next speaker, Daniel Gomes Pinta from Portugal. He will speak about GenAI application and benchmarking in pathology. The floor is yours. Thank you.
Thank you so much. Good morning, everyone. All right, there it is. So what a fantastic few days of conferences it has been. Before I begin, I would like to thank very much the organization for the opportunity to be here talking about this topic, which I like very much. I am Daniel Gomes Pinto from Portugal, head of department at Garcia de Horta and a PhD student at Nova Medical School. And I hope you find what we discuss here interesting and useful. So this is just a very brief timeline of the path to generative AI from the 1930s, where the theoretical framework for computation was outlined by Alan Turing, to computers that can actually understand what you are saying and talk back to you. It's been less than 100 years. And if this is not an astonishing rate of progress, I don't really know what is. And it always fascinates me. And now we have arrived to generative AI. And these are some examples of the commercial platforms that are everywhere and you all know, and people are using for the most diverse purposes, including professional purposes. We wondered if, this was back in 2024, if pathologists were actually using these models or not. And we found that from our respondents, that 46.5%, and we had nearly 100 people using GPT, that from these 100 people, 46.5% were using ChatGPT for work. Around 50% had adopted it within 1 year of release. So this was a very new technology and people were already using it. And more than 50%, more than half of the cohort, claimed to have saved between 1 and 5 hours of work per week using these tools. So the field is moving fast. People are using the models, including for work. But do we know how good they are? And the answer is maybe not really. In the general domain, this is a problem of benchmarking, and that's why we're talking about benchmarking. And this has developed further along than what it has in pathology. And we can evaluate the models in several domains. There are several well-known and benchmarks with known performances. New models, when they come out, you might have read some of these names. When they come out, they are tested on these benchmarks, and the companies use the metrics as publicity. We can test these models on knowledge. Factual recall is tested by MMLU in over 57 academic domains. ArcChallenge is notoriously difficult benchmark. We can evaluate the reasoning, for example, in multi-step mathematical and logical problem solving, such as in the GSM-8K. We can evaluate code generation. Code generation is a good problem. They like it because you can see if the code runs or not, if it's well written or not. There are multimodal benchmarks for image understanding, such as the MMMU. And you can also evaluate safety and trustfulness, for example, with truthful QA. Some of the key metrics that are evaluated in these benchmarks we are familiar with, some in the pathology world, some we are less familiar with. Accuracy, of course, the most common metric, the percentage of correct answers when it's like multiple choice. The F1 score, which one is perfect precision and recall. This is common in extraction tasks, as we will see just briefly. The pathology benchmark, which evaluates the functional correctness of generated code. ELO scores, like you have in chess, you can attribute these models an ELO score. There are leaderboards composed usually of compound benchmarks that evaluate the performance of these LLMs against each other. And of course, in the general medical domain, we also have some specific benchmarks. This one the first one showed up in the news when the GPT-4 scored over 90% in the USMLE exam. A passing grade is 60%. So this was a big result. And these questions comprise the MedQA benchmark. You have PubMed QA, Multimed Bench, and also some emerging pathology benchmarks like PathBench, which is outside the scope of what we're talking here today, because it's not focusing on generative AI. And we have PathMMU. Well, and so can't we adapt some of these benchmarks to work in pathology? Do we really need to reinvent the wheel? Maybe not entirely, but pathology is different because it requires not just the text, as we will see, but it requires also the visual interpretation of tissue morphology. Our images are different than radiology. They are gigapixel, they are very large. We have a domain-specific vocabulary that we have to master, and our ground truth is sometimes not consensual. It requires an expert consensus. It's broad. And furthermore, to arrive to a diagnosis, as the pathologists in the room will know very well, you have to not only see the morphology, not only see the clinical history, but also integrate ancillary testing oftentimes, such as immunohistochemistry and molecular data. There are no established evaluation standards in our field yet, and so we think we need pathology-specific benchmarks, and we need standards to build high-quality benchmarks to avoid the problems that the general domain faced, because we do not have the resources of the general domain. We should learn from their mistakes. And this is why we conducted we are conducting the first systematic review of generative AI in pathology. And this is more or less, this is the preliminary data that I bring to you today. The preliminary data is not what I'm going to report on. It's the preliminary data is on the systematic review, because the papers have, of course, been published or available in the archive for quite a while. And so this is preliminary or Prisma Flow. We have over 1,000 records. We sent out a broad net. We wanted to include as many papers as possible. We then suffered on abstract screening, but that is part of life. And we excluded almost all of them. From the 116 full text papers that move full text review, which is the phase we are at currently, I think this is my own work, a preliminary. We will exclude around 38 because they are not either not on a pathology domain, the model is not the subject of the benchmark, or it's not a generative model. And so we are left with 72 unique studies over 10 clusters. And the 10 domain clusters are these ones. The most numerous one is what Ehsan mentioned previously. His papers fit right in here. The report information extraction. We will discuss this briefly. We will also discuss visual diagnosis, MCQ, question answering and exams, whole slide image visual questioning and answering, fewer papers, but also important, and safety. Just so you can take a look and see how many publications there are per year. In 2025 alone, there have been as many publications as all the years prior combined. Most of these publications are coming from the United States, from China, Europe, and Asia as well. Africa is not yet represented in this list of countries, but hopefully it will be soon as this technology becomes more widespread and available. And so, moving on to pathology report information extraction. This is our dominant cluster. What was evaluated in the papers that we saw. These models were used for extracting cancer staging variables, extracting several different named entities from free text reports, to extract coding, to help in coding, and to also extract biomarker information, such as molecular mutational status and HER2 status as well. And so these are some of the metrics worth highlighting. On this first publication by Hein, they were trying to extract from free text reports renal tumor subtypes, and with a zero-shot approach, so just one prompt and extracting the response from the model, with a significant pipeline of prompt engineering, which is interesting enough that I would like to highlight it to you. So they developed an entire pipeline where they would just give the model the report text and the original prompts. They obtain the output. They would compare it to the ground truth. They would fix it, refine the prompt, and they did this iteratively until they arrived to a good prompt which solved the problems and enabled them to get a near perfect F1 score of 0.99. With GPT-4o, although with Llama 3.370b, which is an open source model, they were able to get pretty close to this, within 5%. And a similar result was reported by the next publication, in this case, in extracting breast pathology variables, also from free text, with a 96.1% agreement with the ground truth. This for GPT-4o and also Llama 3.1b, although they use a larger Llama model, this is 3.1, 485b, if I'm not mistaken. For the purpose of extracting mutations, the next result is very interesting. An F1 score of over 0.95% with a zero-shot approach. But what is different in this paper versus the other ones, that these ones are using very large models, whereas that one is using a very small model, which is Llama 3.8b, open source small model. And what they did was they fine-tuned it for this specific task. But in the end, using this fine-tune with this small model, they achieved performance that is comparable to much larger, what we say, foundational models. This is replicated, a slightly larger open source model by the next publication, which was able to extract information from 193 cap fields across 10 organ systems. And also the last from Grothy, who achieved an accuracy between 97 and 98% using a zero-shot strategy with prompting engineering for GPT-4 and also Llama 3. They were nearly indistinguishable. So open source models also prominent here. And so what we can see from this publication is that large models, both commercial and open source, reach near expert performance on structured extraction. This is similar to what Hassan just showed us with his papers. And this open source comparison is worth pointing out. We can see it's not a fluke, it's not cherry-picked data. We can see it on the rest of the papers included here. His is over there, Tripathi, you can see and on the open weight column. And this is the reported accuracy on the different series. You can see that the numbers match almost precisely. So large open source models work very well. And as we saw before, if you fine-tune a small model for a specific task, it can also perform it well. We still haven't addressed prompting strategies. We've talked about prompt engineering. We've talked about model size and architecture. We didn't discuss prompting strategies, like zero-shot versus few-shot, for instance. The message here is that it can make a difference. As we see over there in Park. Park has this older, smaller model, Llama 2, and here few-shot made a huge difference. But these reports were in Korean, and Llama 2 has very little Korean in its training data, and it's a much smaller model. Not necessarily small, it's a much more primitive, let's say, model, versus Llama 3. In Llama 3, Grothley, from before, using a small version of Llama 3, 4-bit, it's actually made it worse. So no size fits all, that's the message here. And we have to validate prompting strategies for each solution. All right, moving on to what I think is probably most important to pathologists, which is multimodal visual diagnosis. Are these things going to replace us? Well, not yet. We can see that their performance is always below the pathologist's performance, or tendentially below the pathologist's performance. Although if we look at these very specific tasks, like the classification of lung histopathology lesions in a small series, using non-random regions of interest, that is, the pathologist selected these regions of interest, then the performance is 11, 12 points below what the pathologist can do. For tissue origin identification, the model achieves, this is GPT-4, achieves a performance that is interesting, but still less than residents. One interesting and slightly discrepant result is this one by Nguyen in 2025, where they selected regions of interest from a textbook on oral pathological lesions, histopathology lesions. And here, O3 actually had a better result than the pathologist. This is interesting because the result is very bad compared to the rest of the publications. And we're left to wonder if this is a good test or a bad test, or just a demanding test which was applied somehow. But another interesting thing about this paper is that they asked the model to explain and to talk a little bit about the logic behind their diagnosis. And they graded this, is it good or is it bad? And they found that the explanations were quite good, but the model was just discussing the wrong entity. And they attributed this to a problem in the encoding, the visual encoding, which is something we also found. This is a poster we presented at the ECP last year, where essentially we grabbed a small series of 65 breast biopsies. We developed a semi-automated pipeline for segmentation and tiling, because you have to give to these foundational models, commercial ones, in tiles. And we selected the most representative ones through a ratio. It works more or less. And then we fed them to the models. We picked two, GPT-4o and O1. These have the same underlying foundation, but O1 is chain of thought, whereas GPT-4o does not. And then we changed and varied the prompting strategy, and we did also retrieval augmented generation. And we thought that maybe with the prompting strategy, telling the model how to approach the breast biopsies, giving it a list of entities, it would do better. There is no statistical significant difference between these models and between prompting strategies and between retrieval augmented generation. And we also think it's because the visual encoding is very limited. Our pathology images are just not well enough represented in these models training data. So where have they shown to be useful? In very narrow, simple tasks. For instance, in the estimation of liver fibrosis in serious red, with in-context learning, they did very well, improving over the zero shot, and outperformed the pathologists. For biomarker counting, of course, I would say this is like hammering a nail with a spaceship, using an LLM to count Ki-67. But you can do it. And the last one is they simplified the problem. So they wanted to see neoplastic versus neoplastic. And for neoplastic, it had 100% sensitivity in digital H&E from fluorescence confocal microscopy, a frozen section context in pediatric lesions. So I think it's easy to see from these data that success is inversely related to task complexity and feature conspicuity. So the less complex and the more conspicuous a given feature it is, the easier it will be for these models to find. And now moving on to the really interesting results, which are two publications which you probably heard about, PathChat and SlideChat. These made big waves recently. PathChat I'm presenting here is from 2024. It's basically, it includes a vision encoder, uni-encoder, coupled to Llama 2. Which is an older model, but still, they developed this benchmark. They developed two benchmarks. This is one of them. It's comprised of multiple choice questions, of clinical information, and non-random regions of interest, which are fed to the model. And they compared their model, their implementation with GPT-4v, and you can see that the vision encoder, as we stated previously, makes a huge difference, the domain-specific vision encoder. And PathChat was able to achieve a 93.5 versus 63.5 for GPT-v4. And you can see here how it was tested. So this is the benchmark itself. They have multiple choice questions. They feed it to the LLMs, and then they plotted this graph. And you can see here the performance of PathChat just obliterates the non-domain specific models. SlideChat is also very interesting because it uses a long net, a diffuse attention layer to enable the model not to be fed patches, but to be fed the whole slide. Or to have access, I would say with less granularity than if you were to feed patches, but to have conceptually access to the low and high magnification at the same time. Coupled with also a vision text encoder conch, and then with a Quen, also an open source model. And they developed their own benchmark. You can see here 81.2% versus 57.9%. And here in the spider plot, you can see that it also crushes the other models, although this is not really a fair comparison because they enable the model to have access to the whole slide. It is also worth noting the developments in PathChat, which is PathChat Plus, which was released just this year, where they also found a way to give the model access to the whole slide, but not through the long net type approach, but through an agentic system, where the model selects what it wants to see from the whole slide. In my opinion, if you allow me, I think this is the more interesting approach. And they've developed a more demanding benchmark, which is DDX Bench. I present the data here on regions of interest because it's the only one that has comparison with other models. And you can see that this is quite a big difference. And if you want to look at what is the performance with the whole slide, you can see it's here. I can point it, but it's 86% correct in the overall data set and 94.1% accurate in the more common lesions. This is a result from cytomorphology evaluation on identification of cells, for instance, and you can see here that the domain-specific model, DynoBloom, which is not, as I would say, newsworthy, but also crushes the other models, once again showing the importance of domain-specific visual encoding. And this is a problem that, as was mentioned yesterday, may be mitigated with the advent of pathology foundational models. Okay, so going a little bit beyond diagnosis to knowledge testing of these models. We have MCQ benchmarks. They are quite common. They were some of the first publications that were done in this area. And I put this result here because I do think that there are a few things worth highlighting, which is that these models seem to harbor in their statistical framework some knowledge on pathology. They are able to answer these small benchmarks of multiple choice questions, either if they are text only like the first result or multimodal like the last one, and they get really good percentages over human comparison, if you can see here. Although we have to keep in mind that in many of these publications, and if you look at the literature, you're going to see many of them, small series mostly, there is a contamination risk. And if you are thinking about evaluating an LLM, you have to always consider this, which is these models are trained by scraping large amounts of data from the internet, almost all of it. And so if you're testing the model on data that is openly accessible on the internet, then this data is you have to assume it's part of the model's training data. So this will limit the usefulness of these benchmarks. And you can see over there, for example, in the Gustafiero paper, it's a small number of clinical scenarios, but handcrafted specifically, they obtained 894 evaluations, and then subjectively evaluated them to see if they were useful or error-free, and those are the metrics, which are slightly lower than the ones you can see here in the MCQs. And Debord saw the same thing with the multimodal evaluation on an RCPA-style examination. And also, what's interesting for Debord is that a key competency test of this exam is the ability to recognize limitations and uncertainty. And the authors highlight that ChatGPT failed to do so. It never qualified answers or indicated uncertainty when necessary. Instead, it produced misleading, confident language. It's a confident bullshitter, like they say in the industry. And you have to pay attention to this. The model does not know what it does not know. And that can be concerning for medical applications. I have, of course, to mention, since we're talking about MCQs, the largest pathology benchmark that exists out there, PathMMU. This was published in 2024. It was created by extracting also pathology images from the internet and then using GPT-4 to generate question and answer pairs. These were reviewed, a subset was reviewed by humans. This was used to prune, let's say, the benchmark. It's not perfect, but it's the best we got. It has 33,000 MCQs and over 24,000 images. In the original publication, they tested 18 LLMs, and this is the comparison. Experts achieved a score of 71.8% versus 49.8% for GPT-4V. An interesting finding, which I was just telling Nadi, that is similar to what they found in their challenge, which is that if in this paper, if you replace images with noise, there is only a small drop in accuracy. So multimodality wasn't all that important for these models. They're inferring from language, which is what they're really good at. And interestingly, this benchmark is also being adopted by PathChat, Glover, and others in pathology LLM evaluation. If you are curious what PathChat Plus got on this LLM, it's not on the paper. But if you read it carefully, you can infer that it's more or less 60.4%. So not quite expert level, but it's getting better. All right. And so can we trust these models? I've been hinting that we can't. But this is an interesting, you might have read this paper. It's called Pathology's Last Exam, and it tests these models on complex diagnostic cases. They achieve actually a good result, but that's not the part I want to highlight. The part I want to highlight is adversarial testing. So they included random mix-ups in their clinical cases, or they created nonsensical cases that they gave to the model. And the model had to refuse to look at these cases because they are nonsense, right? But they didn't. The refusal rate was 70% for nonsensical and 50% for random mix-ups. And this is quite concerning because you can give these models nonsense, and once again, you can get out confident bullshit, which, if you believe it, might lead you down an erroneous path. And this brings us to we're almost over. Where do we go from here, now that we've seen this panorama? Well, we need to be more demanding with the way we evaluate these models, and perhaps more demanding with the way that we use them. For benchmarking papers, I think when we're testing specific applications, I think we have to at least specify, specify very clearly what the model is. In many papers, you will see it was GPT-4, or GPT-4 has several iterations. You have to give the API number. Did you use the platform? Did you use the API? This is very important. Prompts should be shared. Because if you are not sharing your prompts, then, and there are many publications, not just in pathology, where they report on a specific performance, but the prompts are not shared. And then how can you reproduce this data? You really cannot. Test and retest reliability. Unless an author tells you that the temperature is set to 0, then they have to do test retest reliability because there is a variation in LLM performance between runs. Contamination assessment, as I mentioned, it is very important. And we need to have good benchmarks and the way to solve it. I don't think it has been solved even in the general domain. Human comparisons, of course, are very helpful. I think we need to work on error taxonomy. Everybody classifies LLM errors in the way they want to classify them. We need to have a good distinction between, is this a knowledge error? Is this a deductive error? Is this a logical error? Is this an hallucination? And this is quite important, I think. Adversarial testing, of course, I have mentioned this, and all of this feeds into reproducibility, which is a core of science, and we should not abdicate that for LLMs either. So making just a brief bridge on what all of this means for African pathology. I think report information extraction is ready. There is near expert level performance, and this can be useful in several contexts, as we have seen. And this can be done with smaller models if they are fine-tuned. So this is quite good. And furthermore, open weight models, open source models, can have very good performance in these text tasks. We have discussed, not vision, but in text. And if you want to run a large model, of course, the server can be quite expensive, but once you have it running, you don't need to do anything to it. There is no consumables. So just only electricity. So you can keep running it indefinitely, and this can be an option. And furthermore, I think I highlighted that throughout the presentation, that non-English works, that these models support English, but they have good performances in non-English language. And this is very important for worldwide deployment. So I think that the near-term opportunity is real. In Africa, and I would say all of us, we don't need to wait for proprietary solutions, or I would even say unnecessarily expensive proprietary solutions, which I guarantee you someone will be trying to sell to you if they haven't already in the near future. So this is the key takeaway from this work, which is Gen AI in pathology works for text with some limitations and some gaps in our knowledge about its performance, but not yet for vision. Although there is promise in foundational models and of course in domain-specific applications as well, the evidence base is growing fast, but we need to standardize the way we evaluate these models. Adversarial testing and the safety first, open scientific thinking are important to enable safe clinical deployment. Open weight models have good enough performance. They enable privacy, they avoid unnecessary recurring costs, and they can be an option, including for resource-constrained settings. And so this is Nova Medical School, where we are doing this project. This is part of my PhD. I thank you once again, the organization, for inviting me, and all of you for your time and attention.
Thank you very much for the excellent presentation with some solution for us in Africa and for the benchmarking. I think it's a beginning for us to have a collaboration between us to make perhaps with the African Society of Digital Pathology benchmarking in Africa.
That will be a great pleasure.
Thank you very much.
Thank you.
Is there any questions? Yes, I think the practical way would be okay.
Thank you.
Thank you very much. So we continue. Okay. I invite my friends for a session, panel discussion. Andrei Bishkov and Nadia Layeshi, Remy Milland, and I think Hisham Attar. Can you join me? For panel discussion, industry, public, private, partnerships, and funding models for digital pathology in Africa. Thank you. Yes, we're waiting for Hisham. Looking for Hisham.
Thank you.
Nadia Layeshi. Hisham is here. Hisham, we're waiting for you.
You're the very good fit for this panel, Hisham. All right, I'm helping here with moderation. Let us set up a 30-minute time slot. All right. We have a couple of new faces on the stage, so I will ask you, everyone, just one sentence self-introduction, please.
Jay,
Hisham.
So, salam alaikum, marhaba. I will have to switch in English now, sorry. I've used 50% of my Arabic knowledge, sorry for that. So it's a real pleasure to be here. My name is Rémi Milan. I'm looking after Africa territory for Leica Biosystems. And yeah, I'm very happy to be here. Thank you.
Hello, I'm Dr. Jay Abdin. I've worked with Hamamatsu for 11 years. My contribution to the African territory was being... Can I have this one? Okay. Sorry, is this better? Oh, yes, it's much better. Sorry, I will start again. My name is Dr. Jay Abdin. I've worked for Hamamatsu for 11 years. I have experience in clinical, pharma, and academic installs. And my contribution to Africa was working with the CHAMPS project with the Bill Gates Foundation to deploy a solution that had a clinical purpose. So this is my background.
I am now not as a Afsdp member or president, but I will represent the private sector. So as a pathologist and also entrepreneur, as a data pathologist founder, that we want to digitalize, democratize the access of the digital pathology in Africa. And that's in this panel, the idea is to discuss.
Yes, and I'm a person, I'm a pathologist also, and I'm the head of laboratory of pathology in medical hospital university in Agadir. So welcome in Agadir, and we try to implement it with the pathology in my institution. So welcome.
Many thanks. Let us get started. So we have a few questions to discuss, addressed to our panelists, and I had the opportunity to share a few minutes ago, so maybe you're already prepared to that. At the same time, I'm happy to open the floor if you have some comments, questions, something maybe coming from your experience. Let's see how we can manage this time slot. So I would like to start with a very simple thing, and I would like to make it as concise as possible, because we have some audience maybe not that much familiar with digital pathology, although this topic had been rephrased several times today, and especially, well, for those people who are in the field, it's not issue at all. So I would like to ask each of you, like, what are, of course you could be repetitive, but you can rank your answer. What are the major sources of funding for digital pathology in AI? Let's say like top 3, top 5 sources, based on your experience or based on your knowledge.
The first here is a public health investment, is the health ministry, and also that can validate and give resource and funding for equipment. It depends of maybe Sana will have this experience. The second one is the private sector. So the pathologist paid for the material, for the solution, for the software. And the last one is a new experience, is VC. It's venture capital that can invest in digital pathology. We have this little experience maybe in Morocco and Kenya with Joshua and some other countries, but that's the sources, the money sources of this in this sector.
Okay, to further support Hisham's comments, my experience has been most of the investments I've seen come from philanthropic investments. Some of the biggest ones you would have probably heard is the Gates Foundation, Wellcome Trust, and of course the US National Cancer Institutes, those type of investments. These aren't a problem. This is the truth of a lot of where the money is coming from. We can further develop these as long as these projects are not just scanner deployments, because they will fail. They must have a clinical purpose and expansion strategies. How about yourself?
Thank you, Jay. I think it's correct. We saw a lot of NGOs are part of this adventure. The World Bank can be mentioned as well, the Clinton Foundation, and also other governments. We had projects led by Japan, for example, the European Community, and also exchange between hospitals. American hospitals I have seen sometime helping to go digital. So I think it's very important. And I would like also to come back with your first point, Hisham, about MOH, because what we see very often is, in fact, and probably that's the root cause of why we have this discussion today, that's the justification. The budget is there, It's not, of course, we can always expand this budget, but it's not a reality. So, but it's about, if I'm the head of, a ministry, department of health, or a hospital, is to who I give this budget. And I have to say that sometimes in anatomic pathology, that's a bit more difficult, which is a bit like surprising, so because you are in the front line in cancer diagnosis. All pathologies are the one giving, the next steps. Without pathology, there is no diagnosis. And that's the essence of all why we are here. And I think this is the difficult point to address, and I think this type of congress is also very helpful because it's a second one now, and I think it's important to give the information, to try to convince. It's not like some of the solution like immunohistochemistry, where it's quite easier maybe to find a monetization of the project, rather the value added. In digital, it's more, we have seen that in a couple of days, it's fantastic, it's amazing, great. How do I justify that to MOH? How do I get the funding? And that's the monetization. How do I prove that? How is my return on investment? And that's also a critical point. Yeah.
The point of ROI.
Yeah.
Return of investment.
And we have a special question about it, don't worry. Just to wrap up again, and maybe for Sana.
In my experience, I think I'm lucky because I'm now in the new university hospital. So I give my project with digital pathology, and the health ministry gave me the financement to take a scanner. It's not the only solution, but I have already, with the education ministry, I had another scanner appear in the medical school. So I did my the education and training on digital pathology and on numerous slide before. So I told you yesterday I began in medical school in Oujda with the help of the Belgium Namur, the faculty of Namur, that they helped me. And the idea was in Oujda, and I come in Agadir, and I come with the project of digital pathology in Agadir. So I'm very lucky because in Morocco we have many barriers in public, especially with financement. So I think it's the same thing in Africa, and I hope these barriers will come out with our building the recommendation with the African Society of Digital Pathology.
Thank you very much. And actually, what you are elaborating, all of you, it's very well mentioned with the whole global, and I would say with Asian experience as well. Because one of the early projects by the Asian Society of Digital Pathology was also to make a survey in different countries. It's been mentioned during this Congress or the previous one as well. And one of the questions was about the ways of funding digital pathology projects in your country across the Asia. And yeah, there were these three major sources, either by the government or let's say by the specific institution, or money coming maybe from private sector, from industry and so on. These are top three. But actually, on even top of those top three was that nothing. More than 50% of countries, they said there is no dedicated route to get this money for digital pathology in this specific country. All right, moving on.
Sorry.
Oh yeah, sure, please.
Sorry, I just wanted to say, let's not forget research, because research can be also a way to fund digital pathology. For instance, you can run a demonstration project, and it's a good way to invest on instruments. But then, of course, at the end of your project, you have also to think about sustainability after So it could be also a
Correct.
way to get funds.
It's a very good point, because actually this is the way how many pioneers started their digital pathology journey, I mean, especially in academic environment, something like a decade ago. So with this knowledge in mind, then how to, I mean, probably, or you can disagree, that the major investment is usually perceived as into the scanner, or maybe some different part of digital pathology ecosystem. So then, with what you have said about the sources, how do you see the way to finance the high initial cost of digital pathology ecosystem? And now I want to narrow down this discussion to the African situation, to the continent, to the country, whatever you prefer.
Yes, it's very difficult to find the financement in Africa. In Morocco, we have many, as I told that, we have many barriers. But we in public, we can have financements in hospital and for research, like Professor Khoury said. But in private, it's very difficult. I think Atta can explain more than me.
Although, you know, in my point of view, in the private sector, we have to calculate really the investment and the impact, because we need to have at the end a good the accountant will need to be happy if I invest in something and make money in these things and there is no ROI at the end. But for me, in my opinion, we have to prove that digital pathology is something can be helpful for our pathology lab. Our colleagues say, why I would invest in a scanner? Why would I invest in an IT? Why I push myself to leave my microscope to that? And we try now to convince, like this Congress with you, that the future of pathology is digital, and we will be able to, I don't love this words even, we will win money and we will win time. It's important, but we have to prove it. We have to create some hub for that and prove and give numbers. But I think we must invest not only in scanners, because there is other solutions also that we have to implement. That's it, my opinion.
Yes, and I think in Morocco we are lucky too, because we have the King of Morocco who said that the digitalization is the next step for us, and I think Moroccan medical and clinical and pathologists have to be clear about this, and they have to take this chance. And I think we can put some projects with our systems in Morocco to digitize this in pathology.
I think in Morocco you really lead the path in digital pathology together with maybe South Africa. But in Sub-Sahara, the challenge is really difficult. It's really sad, because it's probably the territory that would benefit the most due to lack of pathologists.
Yes.
And I fully agree with Hisham as well in the return on investment. It's very tricky to calculate that, especially if you are on private as well, because I would ask questions, also to think about is how much does it cost the society to have a late cancer diagnosis, where digital can help to be faster. When we go to this direction, it's very difficult to monetize. It's not easy. But this is this type of discussion that would be helpful. When I'm traveling, who read the slides? If I'm alone in my lab, how do? I come here 3 days, plus 3 days, plus 5 days. Do I bring my microscope? Do I send the slides? What I'm doing. When today you have tools, you go on your mobile and you do the diagnosis or the second opinion or whatever. So that's very important.
That's why you must push and help and also support university hospitals to talk about research, because it's a public health problems. And that's what we try also to do in Africa, that the digitalization also must be led by the universities, or by the public, the private, and the universities.
Exactly, I agree with you, Hisham.
It's not about our sector, I'm doing this, or it's not about marketing. It's about really resolve a real problem of there are shortage of pathologists, the late of diagnosis, and everything. It's important to have also this global vision. That's why we are here in this panel. Private, university, industry, societies to do this.
And I think in Africa the big problem is also the small number of pathologists. So we can use digital pathology for telepathology. It's a solution, though I think you can help us to make telepathology not in Morocco but all in Africa.
Absolutely, and there is also maybe one challenge is to move from maybe CapEx investment to OpEx investment. So it's not as easy and straightforward like it is maybe for immunohistochemistry. So because you have maybe a higher number of slides. Of course, if someone wants just a second opinion, just for 1 slide, 2 slides a week, the model may be not really proving, itself. But this is something that, we have to be creative as well in the way we address this need. I think that's one where also we can help, and each case is different. But it's also maybe good to see that and to step backward, to see it as a part of a solution for the lab, I'm talking about immunohistochemistry. Why not bundling this? Why not we have managed a lot of projects from A to Z. Let's take an example in Turkey, what's happening. We have someone from Turkey seen. PPP is really present, and correct me if I'm wrong, but PPP in hospitals, some new hospitals are built on PPP basis. And they are really leading the way on this. You have Emirates, Saudi, PPP is there. In Africa, it's not that there yet. Of course, the number of slides is not comparable.
All right, Jay, you want to add something? Jay?
Yeah, so CapEx is a keyword and it is a problem, but in different layers. There's a couple of times we heard scanners being mentioned. I'm from a scanner vendor, so my comments may be unusual for others. We can't replicate what we've achieved in the US or Europe. We have to take a slightly different approach to Africa. Within the African continent, each country behaves differently, and there was very key points made. We talked about research, we've talked about the problems, the lack of pathologists, lack of PPE. So biopsies might not even be possible. What problems are we trying to solve? The CapEx element is a problem for me in the sense that you buy the scanners or hardware or the technology infrastructure once, but no one really considers the running costs. To understand the running costs, you should identify the problem you're trying to solve. You don't need to solve everything. You need to provide a problem, a solution towards it, so that you can continuously get funding and the backing you require, whether it's from your Ministry of Health, the World Banks, or whoever it is. It could be the philanthropic investments. But what we need to do is make sure there is clear evidence. Don't try and tackle everything. And we need better, for me to succeed as a scanner vendor, I only succeed, I'm an enabler. I have to work with a consortium of people. There must be buy-in from everyone. The way we think about scanners or technology, sorry I refer to scanners, is where I'm from. Maybe we need to change the way we deal with this. We heard about subscription models. There's a risk to this. But I've heard success stories from South Africa. We've heard about the Egypt and Roche mechanisms in Morocco. Maybe there's a few other countries. Can we not create a hub and spoke model where we can collaborate more effectively, use technology that's there? We are not talking about the volumes that we see in Europe. Maybe we can collectively collaborate more, not just on the scanning, but using education as a tool to train the pathologists or the local staff. I think there are key elements that cannot be forgotten. We have to train people if there's no expertise. If you cannot do biopsies, what other methodologies are there that we can get these samples? How do we get to this stage? If you don't have it, you don't know what problem to solve. So I think we have to slightly take a different approach to this CapEx.
About because there was some quick chat about alternative ways of payment, such as per slide or maybe subscription based, just related to the scanning. Maybe just a couple of words if you want to add about it from the vendor side. Yeah.
Do you want to go first?
Yeah, I mean, that's a case-by-case approach. The difficulty for a company is on different angles. First of all, that's a regulation point. We, I think, all go through distributors as well in the market. And if you come with 1 slide, 2 slides per week, that's very difficult. You know, if you divide the cost of a scanner with 2 slides per week, if you pay 500 euro per slide, that makes absolutely no sense. When you have sometimes, I don't know, in Turkey, but 1,000 slides per day or whatever, that's a complete different picture. In some countries, even operations are managed by a private partnership. So, having said that, that's a case-by-case approach. There can be different ways according the reality of the lab and the needs. You mentioned that. I think I fully agree with that. I mean, it's important. Why do we do that? What do we need? And it needs to be tailored. It needs to be discussed. Yes. The regulatory aspect is very important because at the end, you need regularity on the payment and so on. And sometimes in some countries, it's challenging. Okay.
We have to customize.
Yeah, absolutely.
We have this experience with data pathology in the startup. We have to customize, and depends of the partner, depends of the client, it depends of the need, and sometimes it depends of the price, and we have to adapt it. Sometimes the first question is how the cost. It's sometimes I understand it's logic, but when you have to convince that it's not about the cost, it's about resolving problems. But you have to customize. That's what we have to discuss. Sometimes we have a big, superb solution, but we can't adapt it for the market locally. That's why you have to customize. We are totally. But if you want to be able to install the hub in, we have to work with university, with private, with foundation, something like this. We have to adapt a roadmap for that. That's the challenge is the scanner, if you want to talk.
Absolutely, and we can open the umbrella. I mean, we can think also out of the box while, including, I was talking about immunohistochemistry, but why not considering, digital together? It's just an example.
Yes, you can combine.
You can combine it, and the business case make it maybe different. Why not?
Yes, totally agree.
All right, thank you. We have less than 10 minutes left, and now I can look back to what has been said maybe like 15 minutes ago about ROI. So what are the ways to return of investment in this field based on your experience or your maybe some hot topics you want to throw in for the panel discussion?
I think just to treat things in the ROI. Yes, telepathology is important. It's something really resolving problems locally. Screening, we have a big problem in Africa, cervical cancer. It's still a pandemic and public problem. If you are focused on some public health problem, we can prove that it's okay and we can resolve. And the last one, and for me it's a mission more than a business, is education and try to make the new generation digital pathologists. We will really have a good ROI because they will use this tool, they will integrate it, there is no problem for that. They will not discuss the cost, they will discuss the need.
Yeah, exactly. And don't forget research, like said. Yes, it's important for us because we have many public health problems still in Africa and in Morocco. And we can solve some problems with digital pathology and AI, locally AI, because we don't have locally yet. And all the solutions are exported from other countries.
I think digital pathology is present. A couple of years we were talking about that as a technology for the future, but that's present. And let's do a parallel with the monolayers, for example, technology. 25 years ago, I think this is when I studied with Leica, we were talking about a new technology that will replace the commercial plasmid. Oh, no, it's not for now, I don't see the inflammation and so on, it's not giving me, it's difficult. Today, it's a standard. Same with tracking, traceability, printers. Before, we are all writing with pencil on cassettes, on slides. It's standard nowadays. Nobody is questioning the benefit. And I think with digital, we are seeing the movement now. It's today, and it will become, it's a question of time, maybe in sub-Saharan Africa. I'm separating because in Morocco, the dynamic is there. And South Africa, it's there as well, of course. And some other countries in Africa are also quite good in this, but a lot need to be done still.
Do you want to add something?
They've all covered it very well.
All right. Very good. By the way, I think it could be squeezed along the lines. We don't have pharma representative on the
Yeah,
stage,
yeah,
but
yeah.
we have them here
Yeah.
in the exhibitor hall and maybe here as well. So how do you see the role of this huge piece of, because remember we are talking about industry, PPP relationship and funding models. What could be the role of this source potential?
I can I?
Yes.
So I believe, and we discussed it in Japan last time with the presentation of Vincenzo D'Imperio. Pharma can be, but you have to pay attention also, can be a bypass and accelerator to digitalization, because a lot of biomarkers now will use digital pathology as a solution for therapy. We saw the same thing for here too. You remember when we are for the immunochemistry standardization and all. But in my opinion, they will push also to choose one system, one workflow that sometimes we can not adapt it easily in our countries. So it will be a good help. We are knowing this. We see that with, I can say it with AstraZeneca and HER2 MindPeak programs, MindPeak education solution. But we have to pay attention for that. We are partners. We did it for molecular, and we know how the rules, know how is it. So pharma can accelerate integration of digital pathology in Africa.
All right.
Jay?
So for me, so Hisham's mentioned the pharma. The other one was the philanthropic investments, which is the Gates Foundation. They've already contributed quite a lot. It's how to continue expanding these projects and maybe more involvement for key members from here.
Yes.
I think this would be
Yes,
quite good.
maybe after that
Yeah.
we discuss.
Everything have been said, 3 words: AI, immunohistochemistry, and I'll forget
That's the
last one.
combo that you said.
That's a combo, and biomarkers. So I think this is really important. It's again, and I think business companies have also some
Yes.
connections to do.
Yes,
It's done
yes.
currently as we speak, I think, but that's, yeah.
Okay, 3 minutes left, and it's a complex topic, and I mean discussion like with many branches. Not to make people confused, I would be interested if you share maybe on your company or personal institutional experience, or maybe what you know from your colleagues. Again, we are talking about the partnership and hopefully successful partnership between the industry and let's say user, right? So can you give some examples, maybe just one example from which you have on your mind, of the successful partnership between industry and digital pathology user, laboratory, institution?
Okay, I sound like a broken record, so I will say the same one again. The CHAMPS project was really interesting for me. This is this publication from 2019, and they've further expanded. It was a project, there was an idea where they didn't understand why children were dying, what were the reasons behind it. So they identified the problem, they have a thesis. One, they couldn't do biopsies, so they created something minimal invasive tissue sampling technique. So this was one of the things. The second was there was local or no experienced staff in this field, so they had to provide a training through telepathology. The other one, the third problem they wanted to solve was the inconsistencies in diagnosis, and then the fragmented data approach. So how do you centralize data? What I liked about this approach, they had a vision. How do we implement it? So I was fortunate enough to work with this project since 2014. These involve territories across Kenya, Mozambique, Mali, Sierra Leone, many other African territories, which are quite difficult, including Somalia as well. This wasn't just an experiment. This was a success. It wasn't an experiment. They had all their steps to go and achieve this, and they have. So the publications are in 2019, and I feel like it's important to try and continue to expand on these experiences, because we can start incorporating incorporate other countries, but also have a continuous stream of money coming in. The problem I'm trying to avoid is there's amount of budget just allocated to CapEx, and everyone's forgotten the actual running costs, how to implement it, how do you support it? What happens in 3 years' time? What happens in 5 years? We have to move away from the mentality, we'll solve it when we get to it. It breaks. You can put as many scanners as you want. If you don't have the infrastructure, nothing will work. So.
Yes, please.
I want to share the experience from Turkey. In Turkey, digital pathology project is being talked for over 10 years. But the thing was that it was scanner-centered. And there are a lot of scanners in Turkey and not usable. We should focus on workflow, and for also Africa, this can be the starting point. If you have the workflow, if you have the digital infrastructure, scanner companies will come to you, pharma companies will come to you because you have a valuable data in you. And for the purchasing department, if you go with the idea of buying a scanner, it is too much. But you can ask for barcode readers, you can ask for computers every year, and you will make the tracking, you will digitize the workflow, your pathologist will be happy with the glass slides, and then scanner will come. Short steps can be, and one thing, everyone has a reason for digitization. Find that reason to convince the payers. I think.
Thank you.
Thank you very much.
Well, I think for the sake of time, we can continue this discussion offline. It was a very productive panel discussion. I'm happy also to have people from the floor involved. Unfortunately, we are not making AI note-taking, otherwise we would easily end up with 2 pages of something very important, but I believe you have something recorded in your brain. All right, thank you very much.
Thank you.
Thank you.
Thank you for the speakers.
Thank you.
Thank you. So we continue with the closing Q note. Yes, with Basma Al-Sabah from Iskandariya in Egypt. She's going to talk about charting the roadmap for digital pathology in Africa 2025-2030, recommendation of African Society of Digital Pathology. Thank you.
Very long journey, very nutritive meal. Thank you for sustaining this so long. I'm not speaking about my own point of view, although it's very much in there. I'm speaking on behalf of the board of the African Society of Digital Pathology. So, we are supposed, according to what the boss asked me to do, is to chart a roadmap for digital pathology in Africa, the recommendations of this society. Why should Africa have digital pathology? Because our patients are waiting. Our patients are waiting for solutions. The problem is that the cancer burden is rising, and that there is drastic shortage of pathologists with, again, drastic inequity in distribution. In our case, delays means deaths, means mortality, and this can never be accepted. So, to make a long story short, why cannot we adopt solutions from the first world? Why cannot we function according to the traditional models or the Western models? We will be addressing this, the answer to this why from the perspective of 3 mismatches. The first is a financial mismatch, the second is technical, and the third relates to workforce. To address first the financial aspect, I'm extremely happy, and I made those guys at the back squinting because I kept changing the presentation according to the last very, very nutritive panel discussion. Yes, CapEx. the capital expenditure, the fact that we have a large sum of money that will be upfront paid, definitely well needed, to buy scanners, to buy monitors, barcode readers, the physical space itself to accommodate the digital pathology unit. All of this is the CapEx. This mindset, this economic situation. The problem is, things are expensive. In what way? Suppose we have a high-end scanner, like the 250K costing scanner. Say we received it as a donation. We did not pay anything for this. What about the other barriers to sustainability, as we call them, the logistic gaps we will have to bypass? What's that? Customs, duty, shipment fees. These are to be added to the main lump sum of the pricing of the scanner. In addition to this, suppose we are also lucky and we prepared for this and we had our technicians ready and well trained. Imagine the other situation if they are not, so things will stay until they get trained. Suppose this and that, the major upfront payment got done successfully, and we faced, thank God, no problems with logistics or training. The problem comes with having to maintain the thing. Imagine as low as $20,000. It's not that this is not so much for us, it is so much for us. But compared to the 250,000, it's nothing. But now things can crash on the rock of these annual service contracts that we cannot keep up with. As simple as, for example, that imagine this situation, we received a kind donation in a rural hospital, in a, for example, sub-Saharan African hospital, a donation. The guy is wearing the vest written donation on his back. People are known to be ultra intelligent in our continent. They got trained, well functioning in no time. The problem arises with time and not with so much long time. Again, not being able to stand up to the maintenance contracts, and as simple as this dripping air conditioner, we cannot keep it, we cannot maintain it. Things as simple as that can crash the whole issue. So this is us, this is Africa. So the CapEx trap, as we call it, can make us end with a rest in peace format for our digital pathology session, which we definitely would not like to have. So this was as far as the financial mismatch is related or has to do with. The second point, the infrastructure, the technicalities. In the upper panel of the illustration, there is the first world, again, with excellent speed, excellent stable power supply, and down there is us. Everybody of African descent knows what it means to have a power off. Everybody knows how the voltage suddenly surges just to fry your boards and your chips, and the device is all about the chip. So we are used to having this. So apply or install a USB. Again, this is very expensive. Again, this is very expensive. This is us, this is our reality. As simple as dust. We are full of desert. We are a desert continent. So as simple as these specks of dust that scratch the lenses that are so sophisticated, or the humidity that reaches very high figures from the extreme north to the extreme south of the continent, all of this can mess up with a very delicate industry or formation of such a device like the scanner, for example. This lady has gone the extra mile and conducted a frozen section procedure, and she's awaiting her professor who tutored her or mentored her in her PhD, and she was all full of dreams, and she went back home and she did the service, and I think he was the cause. The scanner went to their hospital. In the first place, it was granted to them, but as you see, it took her this 2 gigabyte slide, it took her 4 hours. And the margins and the things, we needed at least 10, for example. It took us 40 hours for the professor who is composed and patient and waiting for 40 hours to give an intra-operative decision. This cannot be, this cannot be. So this is us again. So the traditional models, as far as workforce, not finance or infrastructure, the workforce, the people, dictates that in Europe and America and Asia, most probably, we have dense networks of specialists. In our case, we are too few, and we are clustered in unequally in areas, and we leave other areas totally bare of service. And we always keep revisiting this Bible, thanks to Dr. Bishkov. There are all sorts of colors. The entire African continent is red. That is at best. We have 10 to 19 pathologists per million persons. But actually, according to the map, we have less than 1 per million. So underserved is an understatement in our case. And then again, this is, for example, my Egypt, the different governorates. The 11th governorate is Cairo, with the highest percentage of pathologists. Up there on the northern coast, number 1 is Alexandria. It is, to a very great extent, it has pathologists. And as you see, as the color yellow fades, the entire country is nearly of different shades of yellow. So we are, again, drastically underserved. And we consider ourselves, along with Morocco and maybe Tunisia, the lucky guys of the continent. So what if we chose to digitize? Which place will be digitized? If you digitized an elite center in the capital, for example, this is what you end up with. The guy sitting frustratingly, luxuriously happy, composed in the air conditioner, drinking something. Whereas most of the service happens in the other arena, where he is sweating, where people are nagging all the time. This is where digital should be provided, actually. So, having gone through the series of mismatched and analyzed them together, the financial, the technical, and the workforce, everything now points to the fact that digital, in our case, the African case, can never be by a scanner, by the product that is called digital pathology. Something has to be done. Digital pathology for us should be the service that makes pathology reaches everywhere. But don't tell me, don't tell us Africa is going to buy scanners exactly like Sweden does or like the States. It just can't be. So, having said this, we proposed the model that is going to be based on pillars. The first pillar is use case first and not buy the scanner and sit beside it. Address where diagnostic delays are and where subspecialty is completely lacking, where, for example, neuropathology is not there at all, where liver pathology is not there at all. Address these things, address the problem and find solutions for it. The pillar number 2, shift the mindset from buying equipment to we want to deliver service to the patient wherever he is. He deserves this. And we were trained and educated to do this. And the technology is there to let us do what we were supposed to do. I believe this is the single most important slide in the presentation, the hub and spoke model which we are proposing. We are proposing that the service is to have a lot of level 1 peripheral units, and then these feed back to the blue ones, which we call the regional hubs, only for a country to have one level 3 center of excellence, be this Egypt, be it Sudan, be it whatever. This is the proposed model. To elaborate a bit about this, the peripheral level 1 centers or units, what goes on there? These places focus on how to prepare slides well, do no harm, attend to patients' tissues well, and to do this, use the basic optics system, be these mobile phones or low-cost scanners. This is number 1. The blue ones, the level 2, to which the peripheral units will feed, are the things where we should equip so that there is high throughput scanners to function efficiently for telepathology and for quality assurance and to train people. The center of excellence per country, or 2 if we are lucky, is that which will handle the subspecialty reviews and will attend to AI, hopefully. Now, I will spend a few moments here in the peripheral side because this is Africa. Africa is all about level 1, the peripheral sites. So this is the most critical part in the chain because here is the problem with electricity, with fiber optics, and with dust, and with everything. So if this level fails, everything else based on it and built on it will fail in due course. How to improve this setting? Then we will do the following. We will apply, like my dear friend Joshua said, so people did it. It has to be done. Do it with the least costly things, with a mobile phone and adapter over the microscope. Do it with a low-budget scanner. Don't scan the entire slide, regions of interest only, and this brings down the size of the image from a 2 gigabyte organism to a 20 to 50 megabyte, which is easier to upload. Coming to the upload, it does not have to be a synchronous diagnostic setting. That is, we scanned it, upload it now. No, we scan it, we keep it. We store it until the network is at its perfect strength, which is most probably at night. All right? We will do this asynchronously. There are solutions to navigate us through. Then, the right model is not the most advanced, it's the most usable, the one that answers our questions. So, to compare between the peripheral sites and the regional hubs, in the peripheral sites, we care for specimen collection. In the regional hubs, we do the diagnostic volume and training. For technology, we use the simplistic attitude with the adapters and the mobile phones and the low budget scanners, whereas the high throughput whole slide imagers are there in the regional hubs. Personnel who are there in the village and in the rural towns, the trained technicians trained to prepare well and to do image acquisition. Whereas your computer scientists and the well-educated pathologists will be in the level 2 hubs. Where will people at peripheral sites fail if they attempt to scan everything? They will fail. And where will people in the level 2 fail if they neglected maintenance? They will definitely fail. We keep reading, we keep seeing things, and we know the first world has come with solutions like cars, big vans that have inside them the scanners, so they are mobile units. They can go from one hospital to another. The hospital does not have to acquire its own scanner. It does have to prepare its slides cleanly, neatly, so that when the scheduled visit of the scan van or whatever it is happens, everything is ready. Will that work for us? Maybe, but let me tell you something. With these cars, you know that you cannot have vibrations near your scanner. What about our streets, which are not even paved in most of the African rural areas? We are addressing or targeting the rural areas, agreed. So vibrations from rough roads, dust, infiltration, extreme heat, and we are a hot continent, all of this will damage the whole business. So what to do then? The backpack attitude or model. Just put your mobile phone or the low cost or low budget scanner in your bag. The technician goes from there to there with a motorbike, with whatever, and things get done. It's important for things to get done at the end. The pillar 3 is sustainability, and here is where I brought Squint to the guys at the back, because there has to be a financial solution. Addressing this, you address industry, you address the government. So the traditional model for the industry, sorry, don't be offended by this, but we see it this way. You need us to raise big funds, and for us, there is a lot of money drained, and there is high upfront costs with no long-term support. So this is how we end up with. So what should be done now is this, to our thinking. You move from a capital expenditure to operational expenditure, and we heard from the prestigious panel a few minutes ago that you can paper slide, you can use different open platforms, and the price that is assigned to scanning a single slide will cover the hardware, the software, and the cloud storage, which is good. It's about $5, by the way, when we calculated this from Egyptian currency and we converted it. This is from CapEx to OpEx. This is the first solution we are proposing. Uptime guarantee, and we heard this from Temprano yesterday. He said, if it doesn't work, you don't take your money. Jordi. And this is the case. If it was down, the scanner was down for 48 hours, there will be vendor penalties. So this, in due course and with time, can foster and help us develop and cultivate our own local spare part depots and trained local engineers and reliable uptime, better care. Interoperability is the name of the game for us. You cannot close a system for us and leave us there, not knowing how to play with it. And the shared procurement in Egypt. We have a UPA, the Unified Procurement Agency. It helps a lot. It brings prices to a very, very reasonable level, and along with the price of the thing, there comes also the service contracts and so on. This was the industry. What about the government? The government has a lot to do, starting from the sovereignty of the data. It's only the government which can do this, to protect the thing and make sure that it's in safe hands. And some of the things we were discussing with sisters and brothers from the continent, we, pathologists from Africa, should be allowed to move up and about in the country, in the continent, providing our services and not being stopped by simply being denounced certification. And maybe this is for the Afsdp to try to negotiate with the different syndicates and the different medical bodies all over the continent. We should be allowed to help our brothers, whether digitally or physically, so there has to be something related to certification of pathologists all over the continent. And nothing is called install digital without the government attending to the fiber optics and without the government attending to safe and well-functioning power backup and maintenance routes. Workforce amplification and using the appropriate tech governance is a big issue, really. Starting from harmonization across Africa, and we have a big intention and actually steps on the ground as a society to address the African Union to try doing something about unifying the or harmonizing the thing. And as I told you, trusted data exchange and patient-centered protection and data sovereignty and federated interoperable systems. At the end of the day, we would not like to be held or accused of violating national security while we are trying to help other patients. So this has to be sorted out once and for all. Then, the name of the presentation is a roadmap. Digital pathology in Africa over the coming years. This is how we see it. Phase 1 should take us a year. What will we be doing in this year? First, we will stress that we apply the hub and spoke pattern, and that we will focus more on telepathology and on frozen section. The goal is to establish 2 to 3 hubs with their peripheral sites, 10 peripheral sites per hub. You have 2 to 3 hubs to be established over the coming year. This is the plan, hopefully. Phase 2, which should take about 1 to 2 years more, where there will be a structural shift, hopefully, to paying per slide, because we cannot at all afford to buy these high-end devices this way. And phase 3, which will take the longer part of the plan, is AI, and we should not be delving into AI before we settle everything with the workflow. Workflow done, sorted, start AI, first for triaging cases, second for quality assurance, and then comes whatever through research, through whatever. The call to action is the government has its role, the industry, and the society. The society is going to echo our voices, for example, relating to people moving or receiving slides to diagnose freely, without being accused of anything and without being asked to who told you you can see my patient's details and personal data. Okay, so this is a trilateral cooperation. Funding, again, as you kindly highlighted, through whatever means, the things that we highlighted together. The research grants help a lot with the African universities. So it only, as we can see, takes good planning. We need to plan well. To plan well. So, some 3,000 years ago in Aswan, in Egypt, in Abu Simbel temple, this was planned, that at the very day of birthday of Ramses II, which is the 22nd of February, and on the very day of his coronation, which is the 22nd of October, through an aperture in the wall, it was very well calculated that the sunbeam will come to say, "Happy birthday, Your Majesty." This was planned. This has been going on for 3,000 years now. When you see this, the sun is saying hello to Ramses II, to Amun-Ra on his right hand, and to Ra-Hur-Akhti on his left hand, and is not at all saying anything to Bitah on his extreme left, simply because he is the god of darkness. and he has to stay in the dark. And this also was calculated. We can. Planning is the name of the game. The recommendation number 1 to number 19 should be for everybody to scan this code, to be a member of the society so that we can echo your voices and you become members and you can be members of the board. You create policies, you cooperate with these people who really want to help us and are doing so efficiently. Thanks to them. Thanks to everybody here. And thank you very much.
Thank you very much, Vesma. Thank you for all the speakers. Thank you for coming from far ways for this Congress.
So, wow, what a conclusion. Really, it's like the Oscar, right? So, it's the end, I think, but we ended great. When I said to Basma to do that, I don't expect these results, but I'm happy that we got this, and I'm very proud of that. So, Basma, shukran. And oh, no, I'm just the manager of the night. It's a book of John Le Carré. Thanks for all, really. It's a family. I am here with my family. I'm here with, I think what I didn't expect that it was a year of not a battle after a battle, but all the battle in the same time. But that's when we did it is thanks. So thanks for everyone. Norman, Andre, Sansei, Fukuoka, all this, my friends, my team, Basma, others, Sana, Mehdi, I don't see him also, Isra, Selma Belmashi is my colleagues in the labs. She supports me for this period and she does a great job for the routine job. And thanks. Yeah? Yes, they wait all. My wife. It's another story. So just to, yes. Oh, yeah. We, for the first time, we integrate some students with us for the organization. Sana also do a great job locally. And we decide to have this vision, and it's important. We hope that we can redact this and publish this. That's my aim. Thanks all the team. Thanks Andre, because I say we support us to have the partnership with DCCR, and we are also want to really integrate synoptic reports, standardization, and acquisition. It's a big challenge. Before going, well, I will just give you the 3 prize of poster that was selected by our jury with Andre Bishkov, Jordi, and Joe. First, second year, that the Egypt school is good. The first is Egypt. Second is Morocco. Third is Senegal. So the number 3 is, thanks guys for the selection. Thanks. Transforming diagnosis into digital pathology in Senegal, microscopy scan and AI, a preliminary study at the Laboratory of Pathologic Anatomy and Cytology at Cheikh Anta Diop, Université de Dakar. So, congratulations, guys. Wait. Yeah, yes, please, one of them here. Yeah, please. Yes, come. Yeah, come. Please, assieds-toi. Merci. Félicitations.
Take a seat.
For the story, we don't find the poster. Search for. So the second one is from a deep learning based framework for predicting spatial transcriptomic cluster from digital histopathology in glioblastoma. Anas Ourdouche, Marrakesh.
From Marrakesh.
Is here. This guy is amazing. I met him during a congress, and if it's something also, the new generation is this. So please. And the first, again, Egypt. It's like football. Training is 2 stars now.
training-free and fairness time enhancement for zero-shot histopathology classification. Shahd M. Nu'man, that's it. With Basma, Mahmoud Yaqub, and Mustafa Al-Attar. It's not me. It's another Attar.
Another one.
So is there someone of the team? No? Yeah. Please, Ustad.
Yes, please join us.
So, congratulations.
Congratulations for all these very beautiful posters.
Yeah. So there is some MOA was signed before the Congress with different, yes. Please pick a photo. Just a photo here.
Photo? Photo.
This photo here. That's it. And we signed MOA with some local societies and with Senegalese societies of pathology, with Ethiopian societies of pathology, and we try to really create a network concerning our vision and spread it with others. And also we sign with the industry. We can officially say whether it's Afsdp partnership with Leica, Remy can confirm, and also with Amamatsu, with our distributor locally. Thanks again. Thanks for different societies. I hope we try to have this, the poster. Yeah, it's okay. So next Congress, next year, Egypt, May 2027. Yes. Shukran, thank you very much. It was great. Send a big picture for the group.
Yes, join us for a big picture,
Thanks,
the last
Norman.
picture. And thank you for everyone. Pictures with Egypt.
Everyone on the stage.
Everyone on the stage, please, for the last photo. Thank you for everyone. Thank you for coming. Just waiting for the exhibition to come with us for the photo. S'il vous plaît, on va faire une photo de groupe. Vous venez avec nous? On va faire une photo de groupe. Vous voulez pas venir? Yallah, on vous attend. Photo de groupe.
Le cousin de Mehdi, Sophie.